Okay, and welcome back to this lesson on the lower jaw, threaded jaw. So I've got the drawing here open again, and I need to put these two M8 tapped holes through that are 11 million and 50 mil apart, slap bang in the middle of the clamp. So I'm going to go through how I do that. So back here in SolidWorks, I'm going to look at this face here, which is our intermediate face, and that's going to be my reference for the tapped holes for this instance. So up here in the feature ribbon bar, we do have the hole wizard. So I'm going to click on hole wizard. So the type of hole that I need to do is a threaded hole. So you've got quite a few options when it comes to different hole types. Counterbore, countersink, just a through hole, straight tapped hole, tapped with a counterbore. You got your legacy customizable, and then we get into our counterbores with slots, countersink with slots, and just plain slotted now. But the one we want is a straight tapped. Alright, now I'm going to use the Australian Standard, so the AS, so make sure that you've got the Australian Standard selected there. And this is a tapped hole there, so I'm going to change the type to tapped hole, and it does remember the last hole that you used there, so I want M8. Now notice here with the standards for SolidWorks on the metric system, any metric course is considered metric standard. Okay, and so you won't have the pitch designated here. Only the fine threads or special threads will be listed here as on the in the standards here. And even some of those, the special ones, won't even be listed, so you'll have to do that a different way. But luckily the one that we want is an M8 course is there, and I'm going to select the M8. Now we can go into custom sizes here, but for a tapped hole, pretty much identical. If you know that M8 is standard 1.25, subtract that from the nominal size and you get 6.75, rounded off to 6.8. So the tapping drill hole there we could slightly alter if we wanted. Drill point, and we'll go through hole. It's not going to make a lick of difference in this instance, so I'm just going to hide the custom sizes, but you can alter that if you want. The end condition, again, we're going to change this to a through all. So we want this to go through all, and because we did that, it also asks for the end condition for the drill and the end condition for the tapped thread. So both of these are going through all. Luckily down the last, we want the with thread call out. This should be selected, but always a good check to do with the thread call out, because we definitely want to do that inside the engineering drawing, have that thread identifier there. We can add classes, but I'm not going to worry too much about that. They come in standard anyway. We can add a countersink on both the near side. So the near side is wherever we place the hole on, and the far side is the through side, because this is a through hole. If it wasn't a through hole, this wouldn't be an option here. You can add tolerances, but we're not going to go that far into it. So I've got everything I want in the hole type tab so far. Now I want to go and position, place the holes. Okay, so this is a basic 2D scenario for the tapped holes. They're all on the same face. If I had holes that were on a cylindrical face or multiple stepped holes, I would want to go to a 3D sketch here. And if I selected a circular face, it would automatically default to a 3D sketch. What I don't want is a 3D sketch this time. So all I'm going to do is not select this, but just go straight out and select the face that I want the holes to be on. So I'm going to select this face as I said before, and that has automatically orientated normal to that face. Now by default, the next thing that's happened is it's jumped into the sketch ribbon bar and the point tool is active. So you can actually see the point tool on the cursor, and if I was to click anywhere here, it would place a point, which is what SolidWorks uses in the hole wizard to define the positions of holes. So I want 2 in this instances. So I'm going to place one hole here, and I can place a second hole here. Now there's 2 lines of thoughts as to whether you should put multiple holes inside the hole wizard. I ultimately look at what is my end achievement. For this particular part, there's only 2 tapped holes. In an assembly, if I had lots of holes on like a PCD and I needed to attach a lot of nuts and bolts, that's where I would go for a pattern, and the pattern can save you a lot of time when it comes in the assembly side. But for this, when it comes to assembling this is 2 separate components facing 2 different ways, so it's not going to make a difference whether I have this hole here and place a second hole like so on this component there. So that's why I'm going to go here. Once also, the reason why I want to put the 2 holes on this sketch is it means it can control it in the one position, one place. Alright, so I'm going to hit the escape tool now, and that ends the point tool. So notice my cursor's gone back to an arrowhead there. My sketch is underdefined. So down the bottom here, I can see in the status bar, I can see that it's underdefined. I can see my 2 points here. I'm going to click in the graphics area just to deselect this one here. So this point and this point are both blue, indicating that they're underdefined. So what I want to do is I do want to lock them in a particular position. Now remember, I wanted these 11 mil in from the end and 50 mil apart, but I want them on the center of this part. So what I'm going to do is create a sketch, but I'm going to create a center line. I'm going to lock it in on the origin. So another reason why I made that a midpoint extrusion, I've got that symmetry, so now I can click there. Although I could have easily just like this located at this end the midpoint of that line anyway. But here I've got my design intent, I'm keeping my symmetry, so I want to lock that there in. Hit the escape key yet again, and that deselects and exits the line tool. What I want to do now is I want to locate these 2 points on those lines. I can do it 2 ways. I can grab the point, drag it, come back, and when I come near that line, see how I want to lock it in, and it puts that yellow relationship that's there. So if I've got that, I can let go. The second option of doing this is I can select the point, hold down the control key, select the line. I now get the tool tip menu come up, and I can make that coincidence as well. Now this hasn't fully defined it. See, it's still underdefined. I need to now lock it in with 2 dimensions. Start the Smart Dimension tool. I can click this point, drag up, and now type in 11. I want the distance apart, so I'm going to define from point to point, and I click here and I type in 50. So now I've got a fully defined sketch. I hit the escape key to exit the Smart Dimension tool, but I can now see that my points are black, and down the bottom on the status bar I've got fully defined. I can exit now the hole wizard, and I can see that I've got a through hole. So there. Currently I've got the hole wizard still selected in the design tree, so that's why I can see the sketch that was created to define that. So I can click out and that's got that there. I can see that it's a tapped hole because I can see the cosmetic thread, and I've got this outer ring showing there. Note that the outer ring will only show up on the one side. So notice it doesn't come through on this side, although the hole does come through. So that has now created my 2 holes for my lower jaw, the threaded jaw.